After studying this module, you would know about the details of money supply. You would be able to derive the sourcing and allocation of monetary reserves, identify the asset market equilibrium with the help of endogenous money supply, and derive the real LM function which has endogenous money supply. Let us first understand the basics of money supply. We know that money supply is defined as CC plus DD plus OD, or simply CC plus DD, because OD is a very minor component of money supply. The money supply denoted as M is equal to Cp plus Dp. This is our main equation, the money supply equation number 1. Cp is the currency notes and coins held by public, and demand deposits held by the commercial banks are Dp. We signify Cc in our original money supply equation with Cp and Dd with Dp. The initial assumption is that the money supply is fixed and it is exogenous, and the implications are that only the central bank is responsible for the money supply and it is not interest sensitive. The term exogenous can be used for defining money supply which is fixed in a behavioral sense, and the central bank is uniquely determining the money supply. In a technical sense, it means that it does not affect the rate of interest does not affect the money supply. Now, let us derive the money supply and see how it is sourced and how it is allocated. That means how the monetary assets in the economy, from where do they come and where do they go. So, first of all, we again consider our money supply equation, which consists of Cp and Dp. Equation number 2a tells us that Cp is equal to h small h m. Now, this is the currency notes and coins held by the public, which means one part of the money supply, h, which is a proportion of the money supply, is held by the public. And if h is held by the public, then there are only two entities, the banks, commercial banks, and the public. Therefore, Cp is equal to Hm, or Dp, which is deposits lying with the commercial banks, is equal to 1 minus H times M. This is equation 2a and 2b. The CRR or VRR, cash reserve ratio or the variable reserve ratio, is designated as small z. This is 2c. Accordingly, the required reserves which the commercial banks have to keep are a proportion of the money which is held with the commercial banks. Therefore, RR, which is the required reserve, is equal to Z times DP, and RR therefore can also be written as RR is equal to Z times 1 minus HM, as we have already seen. This is equation number 3. Now, how are the monetary reserves sourced? There are two sources of monetary reserves. One is known as unborrowed reserves. Unborrowed reserves are the reserves which are obtained and sourced by the buying and selling of government bonds through the central bank. We are aware of open market operations, and this is about open market operations. Through open market operations, the government augments its liquidity. Of course, this operation is carried out by the central bank. So, RU denotes the unborrowed reserves. And then we have borrowed reserves. Borrowed reserves are obtained by the commercial banks by the process of rediscounting. eligible bills. These first class bills or eligible bills which are already discounted are given to the central bank, and against this the commercial banks are eligible for getting some funds from the monetary reserves from the central bank, and therefore this is known as RB, which is borrowed reserves. So total reserves are equal to RU, which is unborrowed reserves, plus RB, which are borrowed reserves. This is equation number 4, which is about the sourcing of reserves. Now these reserves which are sourced from these two sources are then let out into the economy, and therefore R is again allocated between different uses. The first and foremost is RR, which is the required reserve, which the banks are mandatorily they have to retain, the reserves that they have to retain by virtue of the variable reserve ratio. Then we have CP, which is the reserves held by the public as currency notes and coins. Now in between these two there is RE, which is excess reserves. So banks would have some excess reserve over and above the required reserves. Therefore R is equal to RR plus RE plus CP. This is equation number 5. This is the allocation of the monetary reserves. If we put together equation number 4 and equation number 5, then this is what is known as the reserve identity. As you know, an identity has a left hand side and a right hand side, and these two sides would always be equal. From where these monetary reserves have been obtained and the amount of monetary reserves that have been obtained, RU plus RB will be equal to R always, and where these reserves are going or being allocated in the economy is RR plus RE plus CP. These would also sum up to R always. Therefore in between we have R, which tells us about the total reserves. The total reserves are borrowed from certain sources and they are given to other entities which are on the right hand side. Now we simplify this equation and make it equation number 6a. RU is equal to RR plus within brackets RE minus RB, and plus CP remains as such. Now why are we doing this? Because out of the excess reserves, the borrowed reserves have to be minused, because the borrowed reserves can't be used for lending out by the commercial banks. What we have now is RF. RF are the free reserves. It is these reserves which the commercial banks can use for lending out for various purposes. In one sense, the money that is not exogenous is controlled by the exogenous is controlled by the central bank, but this is that free money which is not controlled by the central bank, but the commercial banks can do what they want with it. And the public's involvement is also there in this sense, that it is from the public that people take borrowings, loans, advances from the commercial banks. So these free reserves are, the reserves which can be lent out, and therefore they also are given out at a certain rate of interest. So it is these free reserves which have got a relationship with the market rate of interest. Hence this is no longer exogenous, it is endogenous, it is sensitive to the rate of interest. These funds that are the funds which are controlled by the central bank are the borrowed reserves, and the borrowed reserves, unborrowed reserves, which are the open market operations, whereas the borrowed reserves are given to the commercial banks by rediscounting the commercial bills of exchange. But there is a restriction on the commercial banks that they should not use this reserve because it is given in a kind of an emergency. So therefore, commercial banks are not supposed to use these borrowed reserves for lending it out. This is only for adjusting their own liquidity. So now if we again examine this equation number 7, it is RU is equal to RR plus RF. Now we have stated it as free reserves plus CP, which is currency notes and coins held by the public. From the earlier equations, now if we consider the parameters, then what we can say is RR can be rewritten as Z times 1 minus H into M. We have already derived this. And then you have the usual RF, and CP is H times M. So the new equation 7a reads as RU is equal to Z within brackets 1 minus H bracket closed M, and then plus you have RF plus H times M. Now this is no longer an identity. Earlier we talked about the reserve identity. This is derived from that, but this is not an identity because it consists not only of independent entities, but it consists of these parameters which are based on the relationship between different entities. Therefore, it is no longer identities. Now, it is a derivation from the reserve identity, but it is no longer an identity. Now, what happens is that the banks have to decide what to do with this free reserves. As a result, we will now just see how the free reserves they enter into the money market, and hence they would be let out on a certain rate of interest, and therefore they are related to the rate of interest, and we would see that the free reserves are positively related to the rate of interest. If we simplify equation number 7a, then we can get the money supply onto the left hand side, and now what we can see is that the money supply is equal to RU minus RF divided by H plus Z into 1 minus H in brackets. This is equation number 8. Now, equation number 8, which is the money supply equation, we can see that with respect to unborrowed reserves, money supply is positively related. With respect to free reserves, it is negatively related. With respect to the H, it is again negatively related, and with respect to Z also it is negatively related. So, this means that there are three factors or three forces which are operating, because H we know is the proportion of money being held by the public. So, the public is involved in money supply. If we talk about something like Z, Z is the proportion which is held by banks. This means commercial banks are also involved in the money supply. Central bank in any case is involved. Now, if we separate the numerator which consists of RU and RF, then this can be rewritten as two different items on the right hand side. Money supply becomes RU upon H plus Z into 1 plus H, and then we have minus RF upon H plus Z into 1 upon H. There are two components of this equation. As we will be seeing that these two components will result in one part of money supply being exogenous and one part being endogenous. Now, let us consider how the free reserves operate. Free reserves, that is RF, is equal to RE minus RB, and here RB cannot be used for lending out, and RB is a function of the rediscount rate, which is R small r d, and the excess reserves or the free reserves over and above the excess reserves are the ones which are interest sensitive, so it depends upon R. Now, suppose there is demand for credit in the money market because it is some boom period, and at this time then people would like to have more of loans from credit from the commercial banks. So what happens is, when the rate of interest goes up, then the banks would not like to keep free reserves. They would like to give away the free reserves. So the excess reserves would go on declining and the RB would remain constant. So the free reserves would go on declining. Hence, when the rate of interest, when there is demand, then the rate of interest is naturally bound to be high. When the rate of interest is high, then the free reserves go down. Now we get this equation number 9, which says that RF is equal to F of R minus D. R is the market rate of interest and minus RD. RD is the rediscount rate or the bank rate. This shows a negative relationship between free reserves and the rate of interest. But when we substitute this into the money supply equation, we get equation number 10. Now in the money supply equation, what we can see is that there is a negative sign associated with the RF, which is free reserves. And if we consider this negative sign, and then with respect to money supply, then the money supply function would become positive. RF has a negative slope and it is associated with a negative sign in the numerator. Negative and negative put together would be positive. So therefore the money supply function would be upward sloping. Now one part, which is the RU, is the exogenous part and RF is the endogenous part. If we normalize this equation by dividing the entire equation by the total money supply, then we can restate the endogenous money supply as a proportion of the total money supply. And this again can be shown as being not an identity but an equation, because there are several parameters over here, H, Z and so F and so on, and these parameters results in a function where the money supply, now the exogenous part of money supply, which is expressed as a proportion of the total money supply, is a positive function of the rate of interest. The central bank controls H and Z, and Z is controlled by the central bank. H is behavioral, it is controlled by the public, and then the free reserves are controlled by the commercial banks. Therefore, all the three entities, the public, the commercial banks and the central bank, are responsible for the money supply. And now if we measure this endogenous money supply, we call it endogenous because it is interest sensitive. If we measure the endogenous money supply as an equation, then we could simply say that money supply is equal to some beta 0, which is the intercept of the equation, and then beta 1, which is a function of R minus RD, and this is equation number 13. And this equation can be put into the asset market equilibrium, and we express the real money supply equation as M within brackets R minus RD upon P, the supply of real cash balances. It is a linear function, it is upward sloping, and then we have the money supply function, which is again M bar upon P, and this is fixed. the rate of interest would increase from R0 to R1, and if it were an exogenous money supply function, then nothing would happen to the money supply. But now with an endogenous money supply function, the rate of interest would increase and the money supply would also increase. Correspondingly, suppose in the product market the level of income increases from Y0 to Y1. The new intersecting money demand function would be MY1, small m y1, which is the demand for real cash balances. At the new demand for real cash, with the new demand for real cash balances, the upward sloping money supply function would intersect at R2. So, the rate of interest does not go up from R0 to R1, which is the case when the money supply is exogenous. In the case of an endogenous money supply function, we find that the rate of interest is restricted to R2, which is less than R1. This shows that this gives us a kind of a hint that if we are talking about the relationship between the level of income and rate of interest, then we are actually deriving the LM function. So, this is a precursor which tells us that if we look at the derivation of the LM function, then we could expect that the LM function would be more sensitive to the rate of interest. Now, let us go to the 4-quadrant diagram and see how we can derive the LM function. We have 4 quadrants here as usual. In the first quadrant, we have an original LM function, and this LM function we have already seen how it is derived. Now, let us consider a new situation where the money supply has expanded and the money supply remains, the nominal money supply remains the same. Yes, money supply has expanded, but it is the real money supply which has expanded, and this is not because of either the price level or the nominal money supply. This is because of a third factor. If you look at the negative y-axis in the 4th quadrant, you would see that money supply is given as M by P within brackets R0, that is the original money supply, and then you have M by P within brackets R2. So, this is the new money supply, and at the new money supply what is happening is that the money supply function has shifted outwards. When the money supply function shifts outwards, then this gives rise to a situation where there is monetary expansion, but monetary expansion in this case is interest sensitive, and as we have seen in the asset market equilibrium, it is interest sensitive. So, therefore, the LM function, which is LM prime, is likely to be more elastic, it is likely to be flatter. Now, let us just see the same effect through a set of equations which gives us the slope of the LM function. The slope of the modified LM function, MD upon P, which is the demand for real cash balances, is equal to small m within brackets YR. We know that the demand for real cash balances is a function of real income and real rate of interest. We know that it is positively related to income and negatively related to the rate of interest. Now, if we consider the nominal money demand, then this whole equation can be multiplied by the price level. Money supply, on the other hand, now is MS is equal to MR, which is that money supply is a function of rate of interest, and we know that it is a positive function of rate of interest. If we consider the nominal money demand being equal to the nominal money supply, then we have P within brackets small m YR is equal to MR. This is the equilibrium condition. If we differentiate, then we have to use the formula for partial differentiation. P square bracket del m by del y into dy, which is the change in income, plus del m by del r into dr, which is the change in rate of interest, whole bracket closed, is equal to m prime r. So, on the right hand side we have differentiated the money supply, and on the left hand side we have differentiated money demand with respect to income and rate of interest. Now, if we simplify this equation, it reads as dr bracket P del m by dr del the r minus m prime bracket closed is equal to minus P bracket del m by del y into dy bracket closed. So, we are taking the similar terms on the left hand side and the similar terms on the right hand side. Now, if we transform this equation, it reads as dr by dy, which is the slope of the Lm function. The slope of the Lm function is equal to minus P bracket del m by del y, which is nothing but k prime, the slope of the money demand function with respect to income, and then in the denominator we have the slope of the money demand function with respect to rate of interest. Now, you would notice that everything else is the same as the slope of the Lm function, only there is one item in the denominator, that is minus m prime. Okay, so minus m prime. Now, if m prime is the responsiveness of money supply to rate of interest, then it is coming in the denominator with a minus sign. So, what we can say on this basis is that in the denominator, because there is an additional term over here which is where m prime is positive, but it comes with a minus sign. So, therefore, this entire expression in equation number 17 is likely to be the rate of change, that is dr by dy, is likely to be much flatter, and this shows that the slope of the Lm function is much flatter than a normal Lm function. So, what all have we seen in this? We have first of all seen how the reserve identity operates, how there are two sources Ru and Rb, and it is allocated amongst the three uses, that is the bank's reserves, the required reserves, the cash held by the public, currency notes and coins held by the public, and excess reserves. These excess reserves are let out as free reserves, and they are negatively related to the rate of interest, but ultimately the money supply function becomes positively related to the rate of interest. This is how we arrive at an endogenous money supply function. And if we consider the Lm function, then we have seen that with endogenous money supply, the Lm function is flatter in comparison to a money supply function, in comparison to an Lm function which is based on a money supply function which is purely exogenous. And so, finally, what we see is that the shape of the Lm function is the same as a nominal Lm function. A modified Lm function has the same shape and it is upward sloping, but when it comes to the slope of the Lm function, yes, it is also positive, both have a positive slope, but the shape of the Lm function is flatter, the slope is lower, and therefore it appears to be flatter.